everyone, welcome back to the channel. Today we're going to look at using Visual Studio to open a CMake project natively. We're not going to be converting the CMake project into a Visual Studio project or solution. We're going to open it directly, and I'm going to show you how to work with it from right within Visual Studio. We're then going to add SDL2 as a dependency, and I'm going to show you how to link against it, how to add the include directories, and ultimately how to compile a small little SDL startup application. So stay tuned and let's dive into it. The first thing we're going to do is we're going to fire up Visual Studio, and then we're going to click Create New Project. Then we're going to create a new CMake project. Be sure to choose CMake project as opposed to a console app or anything else. Hit Next, and let's just call it SDL Fun. And choose the location where you want the project created if you need to, and then click Create. Now it might take a minute on your computer. I know sometimes on mine it takes a little longer to generate the solution. In this case it was pretty fast. And once this CMake overview screen pops up, we can just close out of that, and we have our CMake solution here, or CMake project rather. So this is the top level CMake lists, which creates our project and then adds the SDL Fun subdirectory, which is the actual application we're building. And there's a nested CMake list.txt file in there, which is where we're going to be doing all of our work. Now that we have a basic project set up, the first thing we're going to want to do is we're going to want to do find package, and we're going to say SDL2 required. Now, if I build that, it's going to automatically reconfigure the project, but you're going to see it says build all failed. And that's because it can't find SDL2. The reason for that is on Windows, it's a little tricky finding these libraries that you use from within CMake, because there's no standard deployment path for a library when you install a library. So usually CMake needs a bit of a hint as to where it can find these libraries. So if we take a look at this error here, it says add the installation prefix of SDL2 to CMake prefix path, or set SDL2 dir to a directory containing one of the above files. So CMake prefix path is a way of giving CMake some hints as to where it can find some libraries and includes for specific libraries you're trying to find via find package. So the first thing we're going to do is we're going to go to Start and type environment variables, and we're going to see this pop up here, edit the system environment variables. Click that, click environment variables, and you'll see I already have this CMake prefix path variable set up in here. If you click edit, you can continue to add more paths in here when you click new. So we need to put a path in here. So if I go to this path that I have here, now I can just add my top level path where I like to keep some of my SDKs and frameworks and whatnot that I use. So I'm just going to go in there and hit new again, paste that, and now CMake can recursively find libraries within this path. If I hit OK, click OK again, click OK again, and now if I click generate, again, it can't find it. So the reason for that is, we've added an environment variable, and because Visual Studio is already running and inherited the environment variables as they were set up at the time when it started, we're going to have to close out of Visual Studio and then start it back up again, reopen our project, SDL Fun, and once it's done loading, we can go to project, or rather, once it's done loading, which it is now, and actually it already generated, but just to show you, we're going to delete cache and reconfigure, which actually clears out all of the cached CMake variables, not environment variables, and regenerates the build files. So we've actually now regenerated all of that, and there are no errors. So if I do Control-Shift-B to build, you'll see that now it builds fine. So this now works. It found SDL2. So the next thing we're going to want to do here is add the SDL2 library includes and actual library to our build so that we can link against it and start working with the SDL2 library directly. So Now, there's some confusion here. If you go online and Google how to use SDL2 with CMake, you'll find a ton of different versions of how to add stuff so that CMake can find it, which libraries you're gonna have to link with, how to add them, what they're called. But I've gone down these rabbit holes on Stack Overflow and whatever. Honestly, all you need from this point on going forward to set up SDL2 with CMake is target link libraries, put your target, and then put SDL2 : SDL2. Now that will also set up the includes as well. You don't have to target include directories or anything like that here. If you build that, and obviously we went through the step of finding the library, this will now include the actual SDL2 library to link against it, and it will set up the include directories. So if we go in here and we now try to include SDL, we should be able to find it. We see, you see we have SDL.h. Now if we build, it builds successfully, or rather it doesn't. Sorry, I'm going to show you why. Now this cryptic error here is another source of confusion that I found on Stack Overflow. And again, you'll go down a rabbit hole here if you start Googling this error. You'll find a whole bunch of different suggestions, hacky fixes from some people. The way you fix this is you have to include SDL2 main. You have to link against this library. And the way you do that is you set up SDL2 again, : SDL2 main. Now that will add the SDL2 main library to the project as well. So the first thing it does is it sets up some platform specific things within its own main program by hijacking the main function call. And then it calls your main after, so that it seamlessly integrates into your application as well. This is very important. Some people don't like that approach, but it's a necessary thing that the SDL team has put in order for that groundwork, for that cross-platform thing that SDL does to make it easier to initialize video, do windowing, and all that kind of stuff that it handles for you. It has to do that within its own main, and it does different things on every platform. So you just have to know that you don't have to do anything specifically different within your main program, but you just have to know that that's happening, and you have to include SDL2 main link against it so that that code is actually so that our linker is able to link that main function from SDL into our program. I hope that makes sense. So if we try and build now we still see that we have a problem. It's not able to, this error doesn't really make much sense initially, but all you have to know is once you link against SDL2 main, if you come in here, the main that Visual Studio generated for us when we created a new project didn't have the argument, or the parameters rather, inside the function declaration. So if we say int argc for the argument count, and then char pointer argv, and then array, so this is an array of char pointers, which is going to be a series of strings. If you don't know how this works, this is the number of parameters or arguments you ran your program with, and this is the actual arguments themselves. So now this is the actual signature that that is required in order for that for our main to be able to be linked into the application. And if we rebuild, we'll see that now this that works, and that function signature matched what SDL was actually looking for. Because remember, SDL is calling this main with these two parameters, and if you don't have them the way it was before, it's not able to find it, and then the linker is complaining and saying unresolved linker error, right? Like, which it's pretty clear why that's happening now. So essentially, like I just showed you, we built successfully and we're good. The next thing you might want to do is initialize one of the SDL subsystems. So let's just say SDL init, and we're going to say SDL video. Let's just initialize, or sorry, rather SDL init video, I think, right there at the bottom. And if we just select that or just hit enter, we should be able to initialize SDL. And then we're going to say SDL quit at the end here. So these two calls, if everything is set up with the linker successfully, if we rebuild, we should have no errors here. And we don't. And now if we run this, or just hit Control F5, it's saying the code execution cannot proceed because SDL2.dll was not found. Now, reinstalling the program may fix this problem. We're obviously, it's a confusing error because it thinks something has to be reinstalled. We just have to make sure SDL2.dll, the runtime library for SDL, is available to our program at startup. Now, the easiest way to fix this error is to just copy the DLL file into our output directory that Visual Studio generates. If you go Googling how to do this, you'll find people use some CMake build scripts to copy the file around and putting stuff like that into the build system. I don't know if that's worth it. Honestly, the simplest thing is to just take the DLL file that comes with our SDL2 installation and just copy it into the path where our executable is being generated by the compiler. So if we just open our folder, so this is the SDL fun folder that Visual Studio generated for us. And if we go to the out folder, build, and then our build type is x64 debug, as you can see up here. So whatever build type you're using, you should always go into that folder. And then inside of the SDL fun again folder, you'll find this is the executable. And if I run that, I get the same error. It's running the same executable. So if we put the DLL in here, and so if I go inside my SDKs folder, SDL2, lib, x64, and then copy that DLL into this folder. Now, even if I clean the solution, it doesn't actually delete those files. It deletes a bunch of other stuff, but like the executable, but it's not actually deleting the DLL, which is good, right? So you can continue to work and you won't have to constantly copy this file around. If it ever disappears for whatever reason, just copy it again. It's not a big deal. But anyways, it's in there. And if you do end up shipping, obviously, something with SDL, you'll have to include the SDL2 file, or make sure that the users have SDL somehow installed in their system. Now on Unix or Linux systems, or even I think on Mac OS, once you install it with a package manager, it's available system-wide because the directory structures for libraries and shared objects and things like that on Linux are much more sane than there are on Windows. But on Windows, you'll just have to either make sure that SDL2 is shipped with your application, or let the users know that SDL has to be installed somehow where the DLL is available at runtime. So anyways, now that this is copied, we go back to Visual Studio, hit Control F5 to rerun, or recompile rather, and run, and we see that there was no error, which means it found the DLL. Obviously, we're not doing anything like creating a window or anything like that, but the application is running, SDL gets initialized, and then it quits. So we're successful. So something I didn't get a chance to record yesterday is adding in some of these calls to create a window and a renderer, and actually doing something a little meaningful with the renderer, albeit we're only drawing a single point with this example, but we are drawing something, and I want to show you that this is all sort of it comes together at the end. So I've added a little bit of coding here. Now, all the error checking that you'd want in a normal application that you actually send out to users isn't in here. You'd want to check if the window was successfully created and if the render was successfully created before using the window in this call. You'd want to make sure SDL init didn't error out for one reason or another. All these things can happen, especially with users using a whole different variety of drivers and running this on multiple different platforms, or if you end up using SDL to do OpenGL or Vulkan, and then you create a window that has those parameters set in there so that it actually sets up for Vulkan or OpenGL. You could run into a lot of different errors. So it's very important that you do add some error checking in here and make sure that you don't have a a null window return and whatnot. But for the sake of keeping this short, I've only put these in just so you can actually see that this is working. I've added this loop in here, so I've got while running, and this loop will continue going until running is false, while running is not false. And then in here we've got this little check where we poll for SDL events, and then in the case that we have an SDL quit event, we set running to false. SDL quit gets sent when you click the close button on the window. So when you click close, and if you don't handle this event and break out somehow, nothing will happen. So we're making sure to capture this event, and then we set running to false, in which case at the end of this loop it'll actually resolve. This loop will find a false value instead of our running variable, and then it'll exit out, in which case we're going to destroy the window and we're going to SDL quit. And in fact, I think what you also need here is SDL destroy renderer, and then pass in the renderer, which I forgot to do. And let's change the order of those, because the renderer was created using the window. So we're going to delete the renderer first, then we're going to delete the window just to keep things in the right order. Let's rebuild with Control-Shift-B. And now if we click this play button here, it says current document. You could even change it directly to the actual target, but it doesn't really matter. So click here, or just hit Control F5 to run without debugger. We see our application runs. We've got an 800 by 600 window displayed at the center of the screen. And we've got a little dot. I'm not sure how it's going to look at the end, but it's over here at 100 by 100 pixels. And our screen has been cleared to a black color. And we're drawing this red dot. So clearly our SDL application is working. And just to show you a couple more things here, when we create the window, we're setting the X and Y position of the window to window pause centered, which is a special argument that you can pass in here to tell SDL to always, it'll take your window dimensions into account and always center the window in the middle of the screen. Then we come down here, we set the render draw color to black here, and then we clear the screen with that color. And then further down, we draw a single point on the screen to a red. So this is RGBA. So we've got an opaque red pixel that we're going to draw on the screen. And then we actually draw the point at 100 by 100 X and Y coordinates. And then we do a render present. So essentially when you draw, you're drawing on what's called the back buffer. And when you're ready to actually show the user by displaying the results of your drawing into the window, what you do is you have to call render present, which will swap the back buffer and the front buffer. The front buffer currently, before this call, is the thing that the user is seeing, and then when you do these draw operations, you're drawing them on the back buffer, the one that the user isn't seeing. And when you're done drawing, you call render present, and then what that does is it flips the two buffers, so all of the things that you just finished drawing get presented to the user, and the thing that the user was seeing is now the back buffer where you're going to do your next frame of drawing. And you do that, and you constantly flip these buffers so that the user is never seeing what you're drawing in real time. They're just seeing the result of your draw operations at the end of the frame. When you actually call render present, and that eliminates things like certain screen tearing artifacts and etc. etc. But you just know that you have to call render present with SDL in order for whatever you've drawn to actually be presented to the user. So I hope that helps. I hope you enjoyed this video. If you did, please like and subscribe, leave a comment. If there's anything that wasn't explained clearly, feedback is very important. So let me know, and thank you for watching.